Last video, I showed how to divide polynomials. And at the end of the video, I said that it is quite a long, very arduous process. And if only there was a way to make it far, far easier. Well, there is. This video I will show you. This process is called synthetic division. Now, it does the very same steps as long division, but simplifies it, makes it far easier. I will show you an example and then I will break down how they are the same process. This was the last polynomial we factored last video. I'm going to factor it by the same root we found, x minus 5. But using synthetic division, I will show you how we get the same result. So, just trying to show that divided by x minus 5 is the same thing as this. So, starting out, we write what our root is. Not what the term is, what the root is. The root here is 5. On the graph, this means that the graph intersects at 5, positive 5. So, we write our 5 here. And we keep it in that corner. And now we want to write our constants. Not constants, coefficients here, horizontally. So we want to write out just 6 minus 29 minus 7 plus 10. Can you guys see that? Yeah. Oh, not plus 10. Just 10. No signs outside of just negatives. So, how this starts is first we have to bring down the first term. It's going to write a line. Now what we do, we multiply these two terms together. 5 times 6 is 30. Adding down, we get 1. Multiply again, 5. Adding down once more, minus 2. 5 times minus 2, minus 10. Add down and we get a very nice remainder of 0. Now in long division, we write our terms of the quotient from highest to lowest. From here, we go from lowest to highest, starting with our remainder. Now we say this is just our remainder. This here is our constant. This is our x term, our linear term, and this is our quadratic term. And so in full, this is 6x squared plus x. It's a very lopsided plus x. No, this is a very lopsided x. That's what it was. Minus 2. Now, if you didn't watch the last video, this is the very same solution we got using long division. But how? Now let me do this with long division to show you. Just very quickly. Speed round. Make this our divisor. That 6x squared times, that cancels, we get minus 30x squared plus, because we're subtracting, so we get 1x squared, that fits into that just one time. 7x cancel, minus 5x, because we're subtracting, minus 2x, minus 2, get it all out, minus 2x plus 10. Plus 10, subtract out, we get a very nice remainder of 0. Cool. Very fast. But, now let's see. All these steps here are still here. Since there's no, coefficient here, this will always fit into this by the coefficient's amount. So that's why we can just bring down the 6 here. Now, this always cancels. So we multiply what we have times our constant here, and that's how we got that 30. That 6, we multiply by our linear term. And so we add it down. That's how we got that 1. That fits into that just one time, so that's why that is just left alone. Multiplying through, 5 times 1 is just 5. Now, do you see that? It already considers the subtraction. It considers that. That's why there's no subtraction here. Only multiplication and addition. This process does already the changing of symbols for you. Then you find that and you get the -2. Leave that there. And then, like we did here, -2 times -5. So we get the 10. Now here, it considers the symbols already. So that's why it's -10 and 10 instead of 10 and +10. Allowing it to just be a remainder of 0. So, it's a very sloppily written solution. But there, synthetic division. The very same process of long division, but it skips the steps that it assumes you already know to get the same answer. Cool. So, now that we know the process of synthetic division, let's factor some more polynomials. So, notice this is the original one, not the factored. We already know the factors, so I'm just trying to show how we can use those as well and get solutions with the remainders. Last video we found the roots were 2x minus 1, 3x plus 2, and so those roots would be 1/2 and -2/3. -2/3, I don't really want to do all that multiplication, so I'm going to use 1/2 as our root. So 1/2 we keep in the box. Now let's just bring our coefficients down. We have 6, -29, -7, and 10. Bring this down. Okay, bring our 6 down. Now, 1/2 of 6 is 3. 29 minus 3, 26, so it's -26. 1/2 of -26, that's going to be -13. Did I do this wrong? Oh, no, I didn't. Never mind. That would be -21. I did do this wrong. My bad, I had a little bit of a brain fart. I said this was -21, my bad. This is just -20. I don't know where I got that from. I don't know. So 1/2 -20 -10, very nice remainder of 0. So this is our constant, or no, this is our remainder. So this is our constant, this is our linear term, and this is our quadratic term. Voila. But wait, this doesn't look anything like our function from before. Well, yeah, we divided another thing out of it. We divided something out of it. Something different, yeah? But that's not what I'm trying to get at. Of course it's different. We divided something different. We divided, this means we divided 2x minus 1 out of that. But we still have this 6 right here. How is that possible? if you don't remember, in long division, we ask how many times does this x term fit into that first term? Like, just in short, we would write, 2x minus 1. Just write the first thing, 6x cubed minus 29x. We ask how many times does this fit into this? Now we consider the 2, right? 2x fits into 6x cubed 3x squared times. Now, these processes are identical to each other, but funnily enough, ironically enough, synthetic division does everything that long division does except for the actual division. It doesn't ask how many times does that fit into that. In long division, it considers our coefficient here and divides it through. Synthetic division does not. If I did this whole process, we would get this whole thing except divided by our coefficient here. So, for the sake of, saving time and actually doing this, the whole long division thing, I'm going to say that we know that we're going to divide each of these terms by 2. So I'm going to save time and I'm going to divide this whole thing by 2. Now, it is not always 2. Our other term was 3x plus 2. If that was the case there, we would then be dividing by 3 when we do synthetic division. We're just doing 2 because it is 2x. So our real solution would be 3x squared. As we can see here, that is our first term, minus 13x minus 10. Boom. Pretty neat. All right, so here is the quadratic polynomial that we found just a couple seconds ago. Now let's try and factor this once more using synthetic division. Instead of using x minus 5, the other root that we found was 3x plus 2, meaning that our 0 was minus 2 over 3. So let's put that one in the box this time. Minus 2 over 3 in the box. Bring just our coefficients down. 3 minus 13 minus 10. Bring the first term down. We just get 3. Minus 2 over 3 times 3. 3's cancel out, so it's just minus 2. Minus 15. The 3 and the 15 simplify, so this is just minus 5 times minus 2, which is just 10, giving us a very nice remainder of 0, making this remainder, this our constant, and this our x term. Now, last time we divided by 2, then we see that we know this has 2 factors. We know the other factor is x minus 5. We solved for that already. But this is not x plus 5, is it? Well, we have to divide once again because this is a rational root. Last time we divided by 2 because it was 2 in the denominator. Because our divisor really is 3x plus 2. So we're asking how many times does 3x fit into 3x squared minus 13x, blah, 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 everything. So like I said, it doesn't do that division for us. So we have to do it at the end. So divide it all by 3. 3's simplified. So now we can say for certain that our new polynomial is x minus 5. Solved. All right, now we have another problem. Now, the reason I'm spoiling our factor series is because I want to show something very specific that happens, not just in synthetic division, but polynomial division on its own. So let's divide by 2, because this is the whole thing. Let's divide by x minus 2 using synthetic division. Our 0 here is going to be minus 2 in the box. And now let's put down our coefficients. 1, 2, minus 4, minus 8. Bring it down. 1, minus 2, 0. 0 minus 4, that gives us 8. Very nice. Now, remainder, constant, x squared. So we get x squared minus 4, and we have a remainder 0, so we know this is correct. Right? Or no? How did we get this term right here? We know that our other term is x cubed minus 4. I don't know if you can see that because the light is there. Yeah, I think, yeah. Our term was x cubed minus 4. How on earth did we get x squared minus 4? Well, there are some things here that we have not considered. Recall, there is not a squared term here. How can we say that we are dividing something from the whole polynomial when some things from this polynomial are hidden? Say, if there is no x squared term, then that means that in there we have 0 times x squared. Because I promise you, when we multiply this out, if we really fully factor this, as ugly as it is, x cubed minus 4, that is something that we can factor. I promise you, you would somewhere find a quadratic term. And when you simplify it, you would get 0 x squared. Now that 0x squared, it isn't just gone. It's still there. And when we are dividing, we still have to consider that. So let's rewrite our synthetic division now knowing that we need to include that 0. So our coefficients are 1, 2, and then the 0, 1, 2, 0, minus 4, minus 8. Let's bring it down. We get 1, minus 2, 0, 0, 0, 0, 8. Adding down gives us a very nice, no remainder. So this is a remainder, constant, x term, squared term, cubic term. So this time, correctly, this is our cubic, we just write x cubed minus 4. And then now we have our correct factor. Isn't that